Okay, so we are going to start. Before we do that, just the standard confirmation, if you can see the screen. So can anyone confirm if you can see the screen?
Yes, sir.
Yes, sir.
Okay, great. Thank you very much. So I'm going to do a very quick recap of last time. And last time we talked about conditional probability and independence. Okay. Conditional probability, which is also a probability, and independence. So we'll continue with these topics today with a few more examples. And we define the conditional probability as you have a sample space, you have a set F, and then you also have a set E. Let's say that there is a bunch of these red outcomes, all of which support F. These F outcomes, they support F. And then we also have these brown outcomes, and these brown outcomes, they support just E and not F, just E and not F. Okay. So we define the conditional probability of E given F. Okay. The conditional probability of E given F means that your world has been limited to F. You are given that F has occurred. What that means is कि अब आपको ये बता दिया कि one of these red outcomes must have occurred. We do know that when we perform the experiment, only one outcome occurs. And what is that outcome? It's one of those red ones which are confined within F. So it is given to you, given that an outcome inside F has occurred, which also means that F has occurred. So this is given to you. And the standard deviation definition of probability is probability of any event is number of sample points which support that event divided by the total number of sample points if all the outcomes are equally likely. By the same token, probability of E given F is now my world is limited to F. So probability of E given F would be number of points, once again, if they are equally likely, number of points in E in reduced sample space. And what is our reduced sample space? In this case, our reduced sample space is F, those red points. And number of points in reduced sample space. So it would be just this shaded area, number of points in the shaded area divided by the total number of points in F, which is the total number of red points. Okay. We also talked about last time, how from this expression you can go to probability of E given F is equal to probability of E and F happening together, divided by probability of F. We also did that last time. Okay. From this you can write probability of E and F is equal to probability of E into probability of F given E. So what this expression is saying is important to understand. This is also called multiplication rule. It's not that, probability of E and F together, you cannot just multiply the probability of E and F. We do know from previous lecture that probability of E and F together, this guy, would be equal to probability of E multiplied by probability of F only when F and E are independent. Okay? But we have not gone to that point yet. Okay? We'll go there today. So this probability of E and F is the probability of the first guy occurring into the probability of the second guy occurring, given that the first one has occurred. So an example of that was a box with red and black balls. What is the probability that you have two red balls? So the probability of the first red ball multiplied by the probability of the second red ball, given that the first one is a red ball. Okay. So very important to understand the meaning of this expression. By the way, E and F, probability of E and F is the same as probability of F and E. So it is no surprise that we can also write is F ko pehle le le. So first you take F and then probability of the second guy, the E given F. Okay. Same thing. This is exactly the same thing. So I'm going to just highlight this here. So last time we did an example of radar detection, and then we said that there is a tree diagram that you can form. We'll have a couple of more examples of tree diagram, and then we asked two questions after that example of radar. We said so I will ask those questions again in a slightly different example. So I'll give you this example. Example is, so let's say you have a box with 8 red balls and 4 white balls. 8 red and 4 white. Pick two balls without replacement. What that means is कि या तो दोनों इकट्ठी पिक कर लें या पहले एक पिक कर लें and don't put it back and then pick the second one. Okay. Or you can pick both of those together, one and the same thing. And now we are interested in the probability. That both are red. Probability of both red. Okay. So let's say R1 is the event that first ball is red, and R2 is the event that second ball is red. How many people think that the probability of that second ball is red really depends upon R1? See, ये example हमने पहले भी की, and the probability that the second ball is red is dependent upon whether the first ball was white or red. So the probability of R1 and R2, which is the desired probability that both red, can be written as the probability of R1 into probability of R2 given R1. Not just R2, it's R2 given R1. Both of these guys are very easy to compute. Very easy to compute. Kaise? So probability of R1, we know this is 8 by 12. 8 red balls out of 14 total 12 total balls. What is the probability of R2 given on R1? Answers in the chat window. R2 given R1. Usama, Umar, thank you. Anyone else? We have 31 people. Only 2 answers. Okay, and that answer is actually correct. It's very easy to find R2 given R1. Okay. If I ask you what is the probability of R2, okay, that is not straightforward to answer. Why it is not straightforward to answer? Answers in the chat window. Why do you think it is not straightforward to answer this probability of R2? Well, we do know how to find it because we did tree diagrams last time. Why it is not obvious how to find probability of R2 is because it is dependent upon the color of the first ball, whether it is R1 or not R1. Okay. So see, the first ball can be red, and the first ball can also be black. First ball can be red or black. And for each of those cases, the second ball can be red or black. I don't know where black came from. We started off with white balls. So red and white. So we can have both red balls, first ball red, second ball white, first ball white, second ball red, or both ball whites. These are only four possibilities. And in these four possibilities, the probability that second ball is red is really given by this guy here and this guy here, both of these. And these paths are mutually exclusive. Mutually exclusive. I can add their probability. So probability of R2 is really equal to probability of R1 and R2. पहला भी red हो और दूसरा भी red हो, plus the probability by plus because mutually exclusive. That first is white, first ball is white, and the second ball is red. First ball is white, first ball is white, and the second ball is red. These are the only two ways that the second ball can be red. The second ball can be red. Okay. And we can compute these probabilities very easily. Why? Because we can say that this is probability of R1 into probability of R2 given R1. Okay. This quantity is equal to this, And this quantity is something that we readily found. Similarly, this quantity here is going to be probability that first ball is white, which is again very easy to compute because we know the number of white balls to begin with, into the probability of R2 given W1. Okay. All of these four items are very easy to compute. So this guy is equivalent to here. Okay. So you can see from the tree diagram, you can compute whether the first ball is white or red. Okay. So I will tell you the importance of this equation. And this is if you are asked to find the probability of an event which is dependent upon the history, such as R2. R2 is an event which is the probability of getting a second ball as red is really dependent upon what is the history. History means what was the color of the first ball. Since there is a probabilistic nature there, the first ball could be anything. Okay. So in this case, I can find out probability of R2, and you will see this thing appearing in many situations that you are asked about the probability of an event, which is dependent upon many previous events. So I'll give you an example. You have a deck of 52 cards. You pick up 5 cards. You pick up 5 random cards, okay, without replacement. 5 cards aapne pick kar liye. What is the probability that the fifth card is number 10? What is the probability fifth card is number 10? This really depends upon what those other 4 first cards were. पहले 4 का जब तक आपको नहीं बताएंगे आप नहीं कर सकते. So you can make a big tree diagram here. Okay. So similarly here, what we do is we break down this probability of R2. Okay, can solve by this process, which is called conditioning on the first ball, by conditioning on the color of the first ball. So what we are doing here, we are conditioning on the color of the first ball. Okay. So the probability of R2 is the first ball can be red, probability of red, into the second ball then can be R2 given R1. Okay. And then the first ball can also be white. Can be white to probability of red given by. So this is the method of conditioning, and we will see a few more examples of that. What we also learned here is the multiplication rule, and there is a slight generalization of multiplication rule. Multiplication rule says probability of A and B together is probability of first and probability of second given the first. This is our, from the standard definition of the conditional probability. Now I can ask a question such as, what is the probability of A, B, and C? Okay. It is natural to think, okay, probability of A, B, and C is probability of A, probability of B given A into probability of C given both A and B, both given A and B, probability of C given A and B. Many difficult problems can be solved very easily by using this technique. And in general, the multiplication rule would be, in general, probability of A1, A2, A3, all the way up to AN, there are n events. This is equal to the probability of intersection of I is equal to 1 to n AN. ऐसे भी लिख सकते हैं इसको, इस A1, A2. So this is equal to probability of the first guy into the probability of the second guy given the first guy into the probability of the third guy given the first two guys, okay, into probability of the fourth guy given the first three guys, and so on and so forth, into the probability of the last guy given all of the previous guys, which is intersection of I is equal to 1 to n minus 1 AI. ये सब दिए हुए, they are all given. Now, how do I prove these? So for example, how do I prove this? In order to prove this, I only need to write the definition of conditional probability. How do I prove this? How do I prove this guy? Again, write the definition of conditional probability. Probability of C given AB is equal to probability of A, B, C divided by probability of A and B. And this guy here is probability of A and B divided by probability of A. So you can see कि ये जो है ये भी cancel हो जाता है, ये भी cancel हो जाता है, and you are left with probability of A, B, and C. Very easy to prove by expansion. So I'll give you an example of this multiplication rule. An example.
सर आप kindly repeat कर सकते हैं कौन सी चीज cancel किया आपने?
ये probability of A, B इसके साथ cancel हो जाएगा, ये probability of A इसके साथ cancel हो जाएगा, you will be left with probability of A, B, and C. Okay.
All right, sir.
So deck of 52 cards, ये जो playing cards होते हैं, pick 3. Okay. Pick 3 without replacement. Or pick 3 cards simultaneously. What is the probability that none of the cards is hearts? So 4 denominations होती हैं, उसके अंदर एक hearts होती है, clubs, spades, and diamond. Okay. So 4 colors in the card, 4 जिसको color कहते हैं, वैसे तो वो red और black ही होते हैं, 2 red होते हैं, 2 black होते हैं. But what is the probability that none of the cards is hearts? There are 13 hearts in the deck of cards, and then 13 spades, and 13 clubs, and 13 diamonds. ये 52 cards होते हैं आपके पास, और ये जो 13 each होती हैं, ये आपके पास ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have jack, queen, and king. So ये पूरे 13 हो गए आपके पास, 13 कार्ड हो गए, और हर एक कलर के यही कार्ड होते हैं. So what this guy is asking us is the probability none of these 3 cards is a heart. So हम define कर देते हैं, A1 is the probability, is the event that first card is not hearts. What is the probability of A1? Answers in the chat window. 39 over 52. What is the probability of A2? Answers in the chat window. Is that 38/51, Osama? What is the probability of A2? Now, this is a trick question. This is a trick question. We may not need it for solving this problem. But what is the probability of A2? Probability of A2 is that second card is not hearts. It really depends upon whether the first card was a heart or not. बिल्कुल उसी तरह जैसे कि दो रेड बॉल्स हमने पिक की थी, probability of R2 given R1 was very easy to compute. But the probability of R2 could only be computed by conditioning. So I cannot compute probability of A2 without conditioning. What was the first card? So let's define this event anyway, that second card is not hearts. We probably will not need probability of A2. Define A3 as the event that third card is also not hearts. Okay. So what we are asked is probability none of the cards is a heart, is probability of A1, A2, A3, which by the multiplication rule is probability of A1, A2 given A1, probability of A3 given A1 and A2, they both occur. A1 and A2 occur. So this guy, probability of A1 is equal to 39/52, जो पहले किसी ने बताया, into probability of A2 given A1. Given A1 means that now you have taken away a heart. Now you have 12 hearts remaining. What is the probability? It's not heart. Well, given A1 means that the first card is not heart. You still have 13 hearts. So this guy, in order to calculate probability of A1 given A2, A2 given A1 would be equal to 38/51, which is not the probability of A2. It's not 38/51. So probability of A2 given A1 is 38/51. Why? Given A1 means कि आपने एक कार्ड निकाल लिया और वो हार्ट नहीं था. इसका मतलब है कि you still have 13 hearts out of these 51, which means that the probability that you will not get a heart as the second card, given that the first was not heart, is 38/51. And then this would be 37/50 by the same token. So you can see, very easy to compute this. Very, very easy to compute this. Of course, you can find probability of A2. Probability of A2 would be condition on the first card. On the first card. Probability of A2 given A1 into probability of A1 plus probability of A2 given A1 complement into probability of A1 complement. Okay. So you conditioned on the first card. The first card could either be A1. ये या तो आपके पास A1 हो सकता है या A1 का कॉम्प्लीमेंट हो सकता है. इसके अलावा और कोई पॉसिबिलिटी नहीं है. अगर कोई और पॉसिबिलिटी भी होती तो मैं वो भी यहां पर लिखता. ठीक है. So it's really dependent upon what is your outcome of the first card. So now I'm going to talk about this. This generalizes to what we call partitions. Or law of total probability. I will generalize this a little bit more. कि जो मैंने यहाँ पे अभी आपको हिंट दिया था कि पहले कार्ड पे या A1 हो सकता था या A1 कॉम्प्लीमेंट हो सकता था, which are mutually exclusive and exhaustive. बट ऐसा हो सकता है कि आप पहले कार्ड के ऊपर आपकी बहुत सारी पॉसिबिलिटीज हो सकती हैं. सो आई विल टॉक अबाउट दैट. partitions. I will talk about partitions. Now, first of all, let me draw this tree diagram. Let's say कि आपके पास स्टेज वन के ऊपर you have possibilities of event F1 happening and F2 happening and Fn happening. F1, F2, F3 all the way up to Fn. ये फर्स्ट स्टेज के ऊपर, फर्स्ट स्टेज के ऊपर कुछ भी हो सकता है. Then on the second stage you have two possibilities. On the second stage you have two possibilities, E and E complement. E and E complement. And similarly E and E complement. If I ask you what is the probability of E, what is the probability of E, how would you go about answering that? Answers in the chat window. कोई hint दे दें कि कैसे calculate करेंगे probability of E. And the probability of E means कि the second stage, दूसरे stage के ऊपर जो हो रहा है वो वहां पे E occur कर रहा है, वहां पे E occur कर रहा है. How will I find probability of E? We know that this is probability of E. This is also probability of E. This is also, all these three pathways, all these n pathways, all lead to E. All lead to E. Sum all of these routes. ये एक route हो गया, फिर ये दूसरा route हो गया, फिर तीसरा, चौथा, पांचवा, छठा, all the way nth route. All of these n routes are mutually exclusive. I can add their probabilities. So probability of E would be equal to summation I is equal to 1 to n probability of E occurring with Fi. This is called partition. Okay. I will show a Venn diagram for this. Okay. And the Venn diagram for this is going to look like this. Okay. You have these partitions F1, F2, F3, F4, and F5. So let's say this is F1, let's say this is F2, let's say this is F3, this is F4, and this is F5. ये हमने 5 लिख दिए. Why have I considered Fs to be mutually exclusive and exhaustive? Because ये F1, F2 ये कोई simultaneously नहीं कर सकते, ये पहली स्टेज के ऊपर जो है, and they have to be mutually exhaustive, वरना इसका मतलब है हम कुछ probability छोड़ देंगे. And if you really look at this example up here, यहाँ पर भी पहले स्टेज के ऊपर जो कुछ हुआ था, that was mutually exclusive. First ball या वो red हो सकती है या white हो सकती है. So coming up red or coming up white, these are two events which are mutually exclusive as well as exhaustive. Tree diagram complete ही तब होती है जब आपके पास ये हर स्टेज के ऊपर mutually exclusive and exhaustive events हो. यहाँ पर भी आपके पास mutually exclusive and exhaustive. Okay. So note that all the FIs, important note is FIs are mutually exclusive and collectively exhaustive. So the union of I is equal to 1 to n Fi would be equal to your sample space S. ये आपकी sample space के बराबर. Now I'm going to define an event. एक event define करते हैं ऐसे. This event is E. So I can write E as this area, ये जो मैंने shade किया है, red में जो shade किया है, plus ये green में जो shade किया है, plus ये brown में जो shade किया है, plus ये blue में जो shade किया है, and plus pink में जो shade. Okay. So all of these areas together, they make up E. Venn diagram हमें ये बता रही है. So the probability of E would be equal to. So what is the red area? ये वाला जो red area है, ये क्या चीज है? This red area. इसको probability की terms में अगर लिखना चाहें तो क्या होगा? Probability of E and F1. probability of E and F1. What about the green area? Probability of E and F2. E and F2. It's not E given F1. It's E and F1. ये intersection है. ये जो red area है, this red area is the intersection of E and F1. This is the intersection of E and F1. This is not E given F1. E given F1 उस वक्त होता, E given F1 उस वक्त होता जब मैं इस एरिया को F1 के एरिया से डिवाइड कर देता, जब मैं इस एरिया को F1 के एरिया से डिवाइड कर देता. Okay, so very important to realize the difference between probability of E and F1. It's not probability of E given F1. क्योंकि probability of E given F1 किसके बराबर होती है? Is probability of E and F1 divided by probability of F1. So this area, red area, is not probability of E given F1. It's probability of E and F1 plus probability of E and F2 plus E and F5, F3 and F4 and F5. Okay. So now you can see that this is equal to summation I is equal to 1 to 5 probability of E and Fi, right? Which is the same expression that we written here. ये तो वही है, ये वही है exactly. So see this tree diagram here and this Venn diagram, they are telling you exactly the same thing, exactly the same thing. Okay. Now, if we believe in this, I can also write probability of E is equal to summation I is equal to 1 to 5. Now, probability of E and Fi, probability of E and Fi can be written as in terms of the conditional probability, which is probability of, so I'm going to write it here. So E given Fi can be written as probability, E and Fi can be written as probability of E given Fi into probability of Fi. इसको लिख सकते हैं. Now if you go back to this expression, इसके ऊपर जरा गौर करें कि मुझे probability of event E चाहिए थी. E is an event जिसको मैंने क्या कहा है कि पहली स्टेज के ऊपर मैं F1 को रख लेता हूं और उसके बाद सेकंड स्टेज के ऊपर E को रख लेता हूं. ठीक है, फर्स्ट स्टेज के ऊपर Fi's हैं और सेकंड स्टेज के ऊपर E है. Second stage के ऊपर ही. This is all in our mind. You know, mathematically I can have E first and F later. E is first and F later. Okay. So now probability of E is probability of E given Fi into probability of Fi for each summed over each value of I. Okay. Now if you recall कि हमने probability of red ball, second red ball, वो हमने क्या लिखी थी? Probability of R2, if you recall, ये हमने लिखी थी कि कंडीशन कर देते हैं फर्स्ट बॉल का क्या कलर था. इसको स्ट्रेट फॉरवर्ड फाइंड करना इतना आसान नहीं है. So I try to find probability of R2 given R1 into probability of R1 plus probability of R2 given W1 into probability of W1. Right? ये हमने ऐसे लिखी थी, इसको ब्रेक डाउन कर दिया था. ये I will go back up here. Right here. So this was exactly the same. वो partitions की example थी, ये जो हमने यहाँ पर लिखी है. So ये more generalized form में ये. वहाँ पे हमारे पास सिर्फ दो possibilities थी कि पहली stage के ऊपर या white ball आ सकती थी या red ball आ सकती थी. In this case, I have 5 different possibilities. पहली स्टेज के ऊपर 5 में से कोई सा भी F हो सकता है. Okay. Now, having said this, I'm going to talk about the Bayes rule. And Bayes rule is very interesting. Yes.
सर आप थोड़ा सा काइंडली ऊपर थोड़ा सा बस
जी।
ये जो आपने यहाँ पे प्रोबेबिलिटी ऑफ ए निकाली है, थोड़ा सा नीचे करें। इसमें प्रोबेबिलिटी ऑफ ए F1 प्लस प्रोबेबिलिटी ऑफ ए F2, इसमें आपने पहले हमें बताया कि हमें प्रोबेबिलिटी ऑफ ए गिवन F1 नहीं करना, लेकिन आपने एंड पे फिर प्रोबेबिलिटी ऑफ, यस सर यही मैं आइडेंटिफाई कर रहा था।
गलत गलत वो या
Alright,
ऑनेस्ट मिस्टेक। हाँ, ये ठीक
alright,
होगी।
alright, जी सर।
सो आपने क्या किया, आपने सारे ये जो एरियाज थे, दीज एरियाज वर डिसजॉइंट, नॉन ओवरलैपिंग, म्यूचुअली एक्सक्लूसिव। ये जो शेडेड एरियाज हैं मैंने जो बताए हुए, एक रेड है, एक पिंक है, ग्रीन है, एक ब्राउन है, एक ब्लू है, इन सबको मैंने प्रोबेबिलिटीज को अलग-अलग ऐड कर दिया, सबकी प्रोबेबिलिटीज को अलग-अलग ऐड कर दिया। रेड वाला में नजर भी आ रहा है कि वो ई और F1 का इंटरसेक्शन है, ई और F1 का इंटरसेक्शन, राइट? ओके, नाउ आई एम गोइंग टू मूव टू बेस रूल। Bayes rule is interesting in the sense कि it will give you, इसमें आप पहली स्टेज का आंसर देंगे। देखें यहां पर तो हमने ये सेकंड स्टेज पे आंसर दिया है कि प्रोबेबिलिटी ऑफ ई क्या है, और ई तक जाने के बहुत सारे डिफरेंट पाथ्स थे, बहुत सारे डिफरेंट पाथ्स थे, मैंने उन सबको ऐड कर लिया। दैट लीड्स अस टू द प्रोबेबिलिटी ऑफ ई कमिंग फ्रॉम एनी ऑफ दोस पाथ्स। नाउ आई एम गोइंग टू आस्क ए रिवर्स क्वेश्चन। द रिवर्स क्वेश्चन इज कि अब आपने सेकंड स्टेज की आउटपुट आपको पता चल गई, सेकंड स्टेज की आउटपुट आपको पता चल गई। सो अगर हम इसको वो बॉक्स में रेड एंड व्हाइट बॉल्स की एग्जांपल लें, सो इफ आई टेल यू दैट द सेकंड बॉल इज रेड, if I tell you that the second ball is red, okay, what is the probability, given that the second ball is red, what is the probability that the first ball was also red? Yeah, first ball was also white, was white. So पहली स्टेज की प्रोबेबिलिटी अगर आपने मालूम करनी हो, given the information of the second stage, how do you find that out? Bayes rule does that. Bayes rule exactly does that. ठीक है? Now Bayes rule आपको कैसे बताएंगे? So again, वही हम partitions वाली एग्जांपल लेते हैं. So this guy again. So in this case, we had written that E is equal to, E is the event which is equivalent to union of I is equal to 1 to n, E and Fi, E and Fi. So यहां पर देख लें कि ये E जो इवेंट है आपका, इस फिगर के अंदर जो इवेंट E है वो इन सारे शेडेड एरियाज का यूनियन है, एंड E एंड Fi, all of these guys for each I are mutually exclusive events, not exhaustive. Exhaustive नहीं है क्योंकि उन सबका यूनियन जो है वो E के बराबर आता है. All the Fi's are mutually exclusive. All the Fi's are mutually exclusive as well as collectively exhaustive. ठीक है, लेकिन ये E and Fi जो हैं ये म्यूचुअली एक्सक्लूसिव तो हैं, बट ये एग्जॉस्टिव नहीं है. इन सबको अगर यूनियन ले लें तो आपके पास E आ जाएगा, आपके पास सैंपल स्पेस नहीं आएगी. सारे F का अगर यूनियन ले लें तो आपके पास सैंपल स्पेस आ जाएगी. सो F's are mutually exclusive as well as collectively exhaustive. E and Fi, these events are mutually exclusive, but they are not collectively exhaustive because in सबका यूनियन E के इक्वल आएगा. So what I have done here is कि यही जो वेन डायग्राम था इसकी मैंने फॉर्म ये लिख दी है. या वेन डायग्राम से देख लें, या अगर आप इस ट्री डायग्राम से देखना चाहते हैं, सो ये मैंने यही वाली चीज लिखी है कि ये प्रोबेबिलिटी ऑफ ईच ऑफ दोज ऐड कर दी है, व्हिच मींस कि वो जो इवेंट E था या सेट E था वो E एंड Fi जो इंटरसेक्शन सेट है उन सारों का यूनियन. देन प्रोबेबिलिटी ऑफ E, ये हमने ऊपर भी मालूम की थी, is equal to summation I is equal to 1 to n probability of E and Fi. This is exactly the same thing जो हमने ये ऊपर लिखी है. Now I can write this to be equal to I is equal to 1 to n probability of E given Fi into probability of Fi. Now think about this probability. This is probability of E given Fi. हमने क्या कहा था, पहली स्टेज पे F's हैं और सेकंड स्टेज के ऊपर E's हैं. ठीक है. So this is the probability of something happening at the second stage given that something happened at the first stage. So what is the probability that second ball is red given the first ball is red? Very easy to calculate. Very easy to calculate. Okay. So probability of E given Fi is what is the probability that something happened later given that something happened before. Given that something happened before. Okay. So Fi happened before and E happened later. Okay. I want to flip this question. जो हमने कहा था कि बेस रूल इस तरह के क्वेश्चन आंसर करता है. What is the probability? What is the probability? If I tell you that E occurs, if I tell you that E occurs, what is the probability that F3 occurred? What is the probability that F3 occurred? So if I ask you this question, what is the probability of F3 given E? This is hard to answer. This is hard to answer. This is hard to answer. In order to answer this, I'm going to make use of the definition of the conditional probability. And the definition of conditional probability tells us that this is equal to probability of F3 and E divided by probability of E. Right? Probability of F3 and E divided by probability of E. Ye conditional probability ka formula. Now, I'm going to flip this around and I will use the following expression. Now, I know finding F3 given E is difficult. Why? Because given the second, अब आपको past बताना है कि किस रास्ते से आई है. So this is the same thing as saying कि if I tell you the color of the second ball, तो अब आपको पहली बॉल का कलर गैस करना है. Hard to do. Hard to do. पहली बॉल का कलर बता दूं तो सेकंड बॉल की का कलर जो है वो आप उसकी प्रोबेबिलिटी निकालना easy to do. Okay. So E given F easy to find. F given E difficult to find. So E given F कैसे निकालेंगे? यहाँ पे इसको मैं चेंज करता हूँ. So I can break this guy here. Probability of F3 and E as probability of E given F3 into probability of F3. Into probability of F3. Numerator को मैंने ऐसे break कर दिया. Divided by probability of E. Now this is easy to find. This is easy to find. This is also easy to find. Why this is easy to find? Because we have already found this by using partitions. By using partitions. I'll give you an example. Example के बगैर नहीं चलता. So let's say you have three boxes. Three boxes. एक में 4 red, 5 white balls हैं. इसको box 1 कह देते हैं. इसको box 1 कह देते हैं. And then you have 3 red and 6 white balls. And then you have 7 red and 3 white balls. So you have box 3, you have box 2, and you have box 1. Okay. So सबसे पहले सिचुएशन बताते हैं कि क्या है. Pick a box at random and then pick a ball at random from that box. From that box. So you may have realized ये उसी तरह की सिचुएशन बन रही है कि आपको पहले F1, F2, F3 तीनों में से कोई एक है और फिर उसके बाद उसमें से एक बॉल पिक करनी है तो E अकर कर रहा है. Okay? So something happening first, selection of the box, and then something happening later, which is the selection of the ball. Okay? So pick a box at random and then pick a ball from that box at random. Okay? So first question that I'm going to ask, what is the probability that the ball you picked is red? Probability of red. Probability of red कैसे मालूम करेंगे? Answers in the chat window. Just give a hint ताकि पता चल जाए कि लोग सुन रहे हैं. 3 routes for each box, then a red from each. ठीक है, बिल्कुल सही है. बिल्कुल सही. So probability of red is found by conditioning on which box was selected. Condition on which box was selected, this is equal to, again, partition से, बिल्कुल ये partition से, probability of red given box 1 into probability of box 1 plus probability of red given box 2 into probability of box 2 plus probability of red given box 3 into probability of box 3. और अगर इसको break down अगर आपने करना है ये 3 म्यूचुअली एक्सक्लूसिव इवेंट्स के अंदर, this is the probability of R and B1. This is the probability of R and B2. This is the probability of R and B3. ठीक है? Convince yourself कि ये जो 3 इवेंट्स हैं ये 3 म्यूचुअली एक्सक्लूसिव हैं. Probably it is very obvious to you कि ये 3 म्यूचुअली एक्सक्लूसिव इवेंट हैं, and these are the only 3 ways that you can get a red ball. कि पहला बॉक्स उठाएं और उसमें से रेड निकाल लें, फिर दूसरा बॉक्स उठाएं उसमें से रेड निकाल लें, तीसरा बॉक्स उठाएं उसमें से रेड निकाल लें. इसके अलावा there is no other way of getting a red ball. These are the only 3 ways to get a red ball. इसकी ट्री डायग्राम बना सकते हैं, ठीक है, जिसके अंदर ये 3 पार्ट्स होंगे. So now each of these probabilities जो मैंने लिखी हैं are very easy to answer. What is the probability of R given B1? R given B1. Answer in the chat window. What is the probability of picking a red ball given that you have selected box 1? Probability of R given B1. R given B1. You are given B1. पहला बॉक्स आपको दे दिया, मैंने आपसे पूछा कि आप बताएं कि उसमें रेड की क्या प्रोबेबिलिटी है. So the probability that you will pick a red is 4 out of 9. It's 4 out of 9. So not multiplied by 1 by 3. Not multiplied by 1 by 3. Why? Because I have already given you the box. मैंने आपको दे दिया है वो बॉक्स, ठीक है. Multiplied by probability of B1. What is the probability that you will pick box 1? Well, there are 3 boxes. One is selected at random, so this is equal to 1 over 3. This is equal to 1 over 3. Similarly, for the second box, it's going to be 3 by 9 into 1 by 3. It's going to be 7 by 10 into 1 by 3. Everyone is okay with that? Great. Okay. Now, second question. ये तो हमने partition से solve कर दिया या conditioning से solve कर दिया. Conditioning on the box के पहली stage के ऊपर आपके पास कौन सा box आया था. Now I am going to ask the base rule type of question, which is कि given that you picked a red ball, given that you have picked a red ball, what is the probability? What is the probability? What is the probability? It came from box 2. What is the probability? It came from box 2. यानी वो आपसे ये पूछ रहे हैं कि क्या प्रोबेबिलिटी है कि आपने पहली स्टेज के ऊपर B2 को सेलेक्ट किया था, B2 को सेलेक्ट किया था. So very easy. We are being asked what is the probability of B2 given red ball, which is the same as probability. यहाँ पे डायरेक्ट बेस रूल लगा दें या it's easy to solve this as well. B2 and R, probability of R is equal to probability of R given B2 into probability of B2 divided by probability of R. Each of those are very easy to find. कैसे? ये जो ऊपर चीज लिखी हुई है R given B2 into probability of B2, this is exactly the same ये जो हमने यहाँ ऊपर पहले लिखी थी. So this would be equal to 3 by 9 into 1 by 3 divided by sum of all these 3. Sum of all these 3, ये P of probability of R ये जो हमने पहले ही निकाल ली है, तो ये यहाँ पे आ जाएगी probability of R, and we are done. It's very easy. So there is another question, actually 2 examples जो हमने notes में दी हुई हैं. We will share those notes sometimes later today. Maybe we have already done that. शायद ये वाले notes हमने पहले share कर दिए हैं, नहीं हुए तो आज हम share कर देंगे. So you are going from Lahore to Islamabad. There are 2 possible paths. You can take GT road or motorway, and there is probability of getting a speeding ticket on the motorway. There is another probability, different probability of getting a speeding ticket on the GT road. So वहाँ पे इसी तरह का सवाल पूछा हुआ है. What is the probability that you will get a ticket if you reach Islamabad? When you reach Islamabad, what is the probability that you would have gotten a ticket? So there are two ways you can get a ticket. GT रोड से जाएं और टिकट मिल जाए, मोटरवे से जाएं और टिकट मिल जाए, दोनों को ऐड कर दें पार्टीशनिंग से. वेरी इजी टू सॉल्व, वेरी इजी टू सॉल्व. दूसरा क्वेश्चन उसके अंदर ये पूछा गया कि you reached Islamabad and you know that you were given a ticket. What is the probability that you took motorway? What is the probability that you took motorway? You can see कि ये फिर आपको एंड रिजल्ट बता रहे हैं कि आपको टिकट मिल गया था और पहली स्टेज के ऊपर जो हुआ था कि जिसमें आपने मोटरवे या जीटी रोड को सिलेक्ट करना था, you have to find the probability of which road you had selected. Okay, so can easily be found by using the Bayes rule. And this example is solved in the notes. Please take a look at that. Please take a look at it. ठीक है. There is a one more example on the Bayes rule in the notes. वो भी उसको भी आप kindly जरूर देखें. So I will give you another example again for the conditional probability. Okay. So let's say you have three cards selected from a deck without replacement, from a deck of 52 cards are picked without replacement. So let's say SI is the event that ith card is a spade. Ith card is a spade. So what is the probability of S1? Answers in the chat window. जी जुनैद, आपने जो ये क्लैरिफिकेशन के लिए जो पूछा है, probability of A and B is equal to A given B into probability of B, or is equal to probability of B given into probability of A. Yes, that is correct. So 13 by 52. People are saying that this is 13 by 52, and I will agree with that, can't disagree. Okay. So now I'm going to ask this question. What is the probability of S2 given S1? कि दूसरा कार्ड स्पेड आए, given that the first one was a spade. Probability of S2 given S1. Answers in the chat window. So देखें, पहला स्पेड आपने निकाल लिया. You are left with 12 spades out of those 51 which are remaining, and we are good. What is the probability of S3 given S1 S2? Answers in the chat window. What is the probability that first two cards were spades and now you pick the third card, and the probability that the third card is also a spade? What is the probability of that? That probability is दो spades निकाल ली हैं, 11 रह गई हैं, और दो कार्ड उठा लिए हैं out of 52, 50 रह गई हैं, so 11 out of 50. Okay, everyone is okay with that? All right. So ये अभी तक ये हमने बड़े simple सवाल पूछे. Now I'm going to ask you this question. What is the probability of S1 given S2? S1 given S2. एक तो हम सवाल पूछते थे, what is the probability of S2? वो हम partition से solve कर लेते थे. ठीक है? So in fact, let me just ask that question as well. Sorry about that. The probability of S2. How do you find this out? What is the probability of S2? How do you find this out? Using partitions. Use partitions. So probability of S2 would be equal to probability of S2 given S1 into probability of S1 plus probability of S2 given S1 complement into probability of S1 complement. So note that S1 and S1 complement, they are mutually exclusive and exhaustive. Necessary for partitions. Partitions के लिए ये necessary है कि all those FIs must be mutually exclusive and exhaustive. तभी हम ये conditioning कर सकते हैं इस तरह. इसी तरह ये देख लें कि इसमें S1 और S1 complement, they are mutually exclusive and exhaustive. So probability of S1 given S2. Probability of S1 given S2. ये कैसे find out करेंगे? S1 given S2. This can be found by using the Bayes rule. Bayes rule से निकाल देंगे. Probability of S1 given S2. Bayes rule से निकाल देंगे. Now I am going to ask you yet one more question. What is the probability of S1 given S2 and S3? Now this is not too difficult a question if you realize that S2 and S3 is an event in future. ये second और third card वाले हैं और आपसे S1 की probability पूछी जा रही है और आपसे S1 की probability पूछी जा रही है which happens first. ठीक है? So again Bayes rule, but थोड़ा सा ये compounded हो जाएगा. Why? ये आपको बता देते हैं. यहाँ पे ये trick मालूम करते हैं. So this would be equal to probability of S1, S2, S3 divided by probability of S2, S3. Probability of S2, S3. This is equal to this. So what is the probability of? सबसे पहले ये मालूम करते हैं. This is 1 and this is 2. So let me ask you what is 1. Probability of S1, S2, S3. ये easy to find है. Answers in the chat window. Answers in the chat window. Probability of S1 into S2 into S3. कहीं आंसर कहीं ऊपर ही लिखे हैं आप. Well, yeah, you will apply multiplication rule. यहाँ पे लगेगा कैसे? Probability of S1 into probability of S2 given S1 into probability of S3 given S1, S2. ठीक है? And we have found all these three probabilities before. कैसे? ये मालूम की और ये मालूम की. So this is going to be 13 by 52 into 12 by 51 into 11 by 50. And we are done. We are done with one. What about probability of S2 given S2 and S3? Now this may not be easy to answer क्योंकि हमें पता ही नहीं है S2 S3 के लिए पहले कार्ड के ऊपर स्पेड आया था या नहीं आया था, पहले कार्ड के ऊपर स्पेड था या नहीं था. So that means S2 S3, think of this as a compound event. और ये फाइंड आउट करने के लिए इस पे आप कंडीशन वगैरह करते रहेंगे, ये नहीं आएगा जब तक आप S1 को नहीं कंसीडर करेंगे. पता होना चाहिए पहला कार्ड स्पेड था या नहीं था. So I will need to condition this. Condition on the outcome of the first card की आउटकम के ऊपर कंडीशन करें. So कैसे कंडीशन करें? This is equal to probability of S2 S3 given S1 given S1 into probability of S1 plus probability of S2 S3 given S1 complement into probability of S1 complement. Once again, S1 and S1 complement, mutually exclusive, exhaustive. So I can write this expression. ये conditioning से जो partition की जो expression है, I can write this. Okay. Now, how do I calculate this? Probability of S1. पता है हमें. Probability of S1 complement. ये भी हमें पता है, हमने मालूम की हुई है. 13 by 52 or 1 minus 13 by 52. What about these other two guys? Probability of S2 and S3 given S1. It's not too difficult to find. आपको मैंने पहला कार्ड बता दिया है कि स्पेड है. What is the probability that second is a spade and then the third is a spade and the third is a spade? So इसके ऊपर फिर दोबारा से आप यूं समझ लें कि मल्टीप्लिकेशन रूल लग जाएगा और मल्टीप्लिकेशन रूल लगेगा. पहला कार्ड आपको गिवन है कि स्पेड है. Now what is the probability that second card is a spade? Is 12 by 51 multiplied by S3 given S2 S1, and that would be equal to 11 out of 50. And probability of S1 is 13 by 52. हमने पहले मालूम की थी. Similarly, you can find these others out. So this will be 13 over 51. अगर पहला कार्ड स्पेड नहीं है, so the second card can be spade with the probability 13 by 51. Why? Because 13 spades are left. Into the third one is a spade is 12 over 50, and this guy is going to be 39 over 52. और ये हम कैलकुलेट कर सकते हैं, ये प्लस ये मल्टीप्लाई. So once this is found, so this was number 2 and this one was number 1. So ये भी आपको पता चल गया और ये भी पता चल गया. Now you can find what is the probability of S1 given S2 and S3. Okay. Very, very interesting example. There is one more example about 3 cards. एक तो ऐसा है कि जिसकी दोनों साइडें ब्लैक हैं, एक ऐसा है जिसकी दोनों साइडें रेड हैं, और एक ऐसा है जिसकी एक साइड रेड है, एक साइड ब्लैक है. Okay, so again this can be very easily solved by using partition and Bayes rule. उस पे दोनों अप्लाई होते हैं. I would suggest taking a look at that. उस तरह के एक दो क्वेश्चंस हमने होमवर्क के अंदर भी दिए हैं. The second homework is out there and we have given a couple of questions related to that as well. Okay. So please take a look at that working example. All the answers are given. It's in the notes that have been uploaded or will be uploaded very soon. So I'm going to just introduce the concept of independence in the context of conditional probability. Independence of events. 2 events can be independent. So let's say you toss 2 coins, probability you have a head on the first one, probability you have a head on the second one. So the outcome of the first coin is not going to be dependent. It is natural to think, it is intuitive to think that the outcome of this coin is not dependent upon the outcome of the other coin. Okay? So, or if you roll a dice and a coin, whatever shows up on the dice is not dependent upon what shows up on the coin. It's not dependent upon that. Yeah. But if you roll 2 dice together, if I tell you that the sum of the dice is 7, if I tell you that the sum of the dice is 7, then probability that the first dice shows a specific number might be dependent, I'm using the word might be dependent upon that outcome. इसी तरह अगर 5 कॉइन्स को टॉस करें, अगर मैं आपको बता दूं कि 5 की 5 कॉइन में से 4 कॉइन जो हैं वो टेल्स आए थे, what is the probability that the third one is a tail given that 4 out of 5 are tails? So the probability that the third one is a tail will not be 1 over 2. The conditional probability have to be found. Okay? Now, what is independence? Independence के लिए हमने ये देखा था कि 2 events are independent. Earlier last lecture में 2 events are independent. A and B are independent events. If probability of A and B is equal to probability of A into probability of B. Probability of A and probability of B. Recall from the conditional probability of expression. The expression of conditional probability is probability of A and B together divided by probability of B. Can also be written as probability of A and B is equal to probability of A given B into probability of B. Compare 1 with 2. If independent, then probability of A given B would be equal to probability of A, would be equal to the probability of A. And this is something which makes complete sense. Okay, the probability of A remains unchanged. Irrespective whether B is given or not. यहाँ पे left पे B given है, right पे B given नहीं है. So probability of A does not change. उसकी सेहत पे कोई फर्क नहीं पड़ता. Okay. So for independence, the conditional probability is the same as the non-conditional probability of any event. Okay. इसकी एक Venn diagram explanation आपको बस intuitive explanation मैं quickly से दे दूंगा. And the intuitive explanation is, let's say you have an event E and another event F in the sample space, okay? So what is probability of E? What is probability of E? Probability of E is the proportion of the sample space which is covered by E, okay? Number of points in E divided by number of points in S. Number of points in E divided by number of points in S, okay? Similarly, probability of E given F, ये क्या होता है आपके पास? ये होता है number of points in E and F divided by number of points in F. Why E given F के अंदर ये क्यों होता है? Because now our world is not the sample space. Now our world is this guy F, okay? And then we are only looking at E inside F, E inside F, okay? So if you compare these two, you can see okay, it's the proportion of E in S, and this is the proportion of E in F, okay? So this is, I'm going to write it here. This is proportion of E in S in the entire sample space, and this is the proportion of E in event F. If these two proportions are the same, then the events A, E, and F will be independent. Okay? I'll give you examples.
सर ये अभी आपने एक कॉइन टॉस वाली एग्जांपल की बात की थी कि अगर थर्ड कॉइन टॉस किया और टेल आया, गिवन के फर्स्ट टू कॉइन टॉसेस वर टेल, तो जो थर्ड की टेल आने की प्रोबेबिलिटी है 1/5 नहीं 1/2 नहीं होगी। इसकी क्या वो होनी नहीं चाहिए, क्योंकि इंडिपेंडेंस वाली जो भी बात की है उसके अंदर तो डिपेंड नहीं करती बात, अगर दो इंडिपेंडेंट इवेंट है। हाँ जी
नहीं, मैंने ये नहीं कहा था, मैंने ये कहा था कि आपने 5 टॉसेस किए, एक ही कॉइन के ऊपर 5 टॉसेस किए। What is the probability that the third toss will result in a tail? 1/2. No issue with that. But if I tell you, मैं आपको extreme example देता हूँ. If I tell you कि all five are tails. If I tell you all 5 are tails, अब मैं आपसे पूछूं, बताएं कि what is the probability that the third toss is a tail? आपका आंसर क्या होगा? 1 होगा ना, तो चेंज हो गई ना प्रोबेबिलिटी। सही है, चेंज हो गई ना। सो इंडिपेंडेंट, इसका मतलब है वो जो मैंने आपको इंफॉर्मेशन दे दी वो एक और इवेंट था कि 5 के 5 कॉइन्स के ऊपर जो है वो टेल आ गई है, 5 के 5 टॉसेस पे टेल आ गई है। वो इवेंट अगर गिवन है आपको, तो प्रोबेबिलिटी दैट यू विल गेट अ टेल ऑन द थर्ड टॉस is going to change, which means that these two events are not independent. It is perfectly all right to think that the tail occurring on each of the toss is independent. ठीक है वो, लेकिन वो और इवेंट है। मैंने तो ये कुछ और इवेंट बताया था, मैंने इवेंट बताया था कि 5 आपके पास टेल्स हैं, उनमें 5 टॉसेस हैं, उनमें से 4 पे टेल्स आ गई हैं। वो भी जो है वो थर्ड कॉइन की जो प्रोबेबिलिटी है वो टेल की, वो चेंज कर देगा, वो भी चेंज कर देगा।
हाँ जी सही है,
ठीक है, ओके। नाउ
सर ये अभी आपने ये जो प्रोबेबिलिटी ऑफ ए और प्रोबेबिलिटी ऑफ ए गिवन एफ में बताया था कि कोई आपने कंडीशन बताई थी, अगर ये होगा तो फिर इंडिपेंडेंट हो गया। काइंडली वो रिपीट कर सकते हैं, क्या कंडीशन थी?
अगर प्रोबेबिलिटी ऑफ ई is the same as probability of E given F, that means E and F are independent. So इसके लिए ये भी जरूरी है, कि product of probability of E and F is equal to the multiplication of individual probabilities. ये मैंने यहाँ पर लिखा था A और B की terms में ना. So A and B are independent. If A and B are independent or vice versa, then probability of A and B together is the probability of A multiplied by probability of B. Probability of A multiplied by probability of B. ये भी true होगा, और probability of A given B would be equal to probability of A. Similarly, probability of B given A would be equal to probability of B. If A is independent of B, then B is also independent of A. I don't know if
Alright.
this was your question or did you ask something?
जी 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 यही था
ठीक है. So I'm going to give you an example. And the example is कि deck of 52 cards. Let's pull a card. Pull one card. हमें अभी पता नहीं है कि वो कौन सा कार्ड. Okay? Define करते हैं. A is the event that this is an ace, and B is the event that this is a spades. Spades जो हैं, there are 13 spades and there are 4 aces. एक spades की होगी, एक clubs की होगी, एक diamonds की, एक hearts की. 4 aces. What is the probability of A? Answers in the chat window. What is the probability of A? Right? Yeah, 4 out of 52. 4 out of 52. What is the probability of B? Answers in the chat window. It's 13 out of 52. What is the probability of A and B together? एक कार्ड पिक किया, वो आपके पास ace of spades आ गया. There is only one ace of spades. What is the probability of A and B together? Answers in the chat window. Is 1 out of 52. 1 out of 52. Is this equal to probability of A multiplied by probability of B? Yes or no? Yes, they are equal. That means A and B are independent. By the way, ये हमारी मर्जी है कि मैं A और B क्या डिफाइन करता हूँ. यहाँ मैंने A डिफाइन किया कि is the event of picking an ace, and B is defined as the event of picking a spades. Now I'm going to change the question a little bit. एक क्वेश्चन को चेंज कर देते हैं. Suppose you discard the queen of hearts from the deck. Before pulling out one card. अभी आंसर नहीं निकालते. फिर हमने एक कार्ड पुल किया है और अगेन उसी तरह से डिफाइन किया है कि A is ace and B is spades. लेकिन अब एक इशू ये है कि अब वो डेक जो है वो पूरे 52 कार्ड्स का नहीं. अब जो डेक है उसके अंदर 51 कार्ड्स हैं, उसमें से मैंने ये क्वीन ऑफ हार्ट्स जो है इसको निकाल के बाहर रख दिया. Queen of hearts को बाहर रख दिया. Now I have 51 cards. Out of these 51 cards, now I'm picking up one card out of these 51 cards. What is the probability of A? What is the probability of B? हम ये निकाल सकते हैं. But so let me just first ask you, what is the probability of A? Simply, what is the probability of A? Answers in the chat window. Probability of A is 4 out of 51. 4 out of 51. What is the probability of B? Probability is 13 out of 51. So I'm not going to ask what is the probability of A and B together. Intuitively जरा सोचें कि are A and B independent? Yes or no? Intuitively क्या लगता है कि ये इंडिपेंडेंट है या नहीं है? Yes or no? Independent or no? Well, mathematically देखना पड़ेगा. No, I don't know how to use intuition here. It's very hard to do that, or at least maybe hard for me to do that. But probability of A and B together. What is the probability of A and B together? Now you are saying कि आपके पास 51 कार्ड्स हैं, उसमें से आपने एक कार्ड पिक किया है और वो जो कार्ड आपने पिक किया है वो एस ऑफ स्पेड्स हो. it's only one card, so it is going to be 1 out of 51. 1 out of 51. Now the question is this equal to probability of A into probability of B? Is this equal to probability of A into probability of B? निकाल के देखते हैं. So this is 4 by 51 into 13 by 51. Okay. So this is equal to 52 by 51 into 1 over 51. Into 1 over 51. So ये है आपके पास 1 over 51. This was 1 over 51, and this is 1 over 51 multiplied by this additional number. So what I observe here is that these two are not equal. These two are not equal. So that means A and B are dependent. A and B dependent. They are dependent. However, I also note something else. And that something else that I note is that कि ये 52 by 51 ये number ऐसा है जो 1 के बहुत close है, जो 1 के बहुत close है, ठीक है? So that means कि A and B, although they are dependent, they are not independent, but their dependency is very, very weak. It's very, very weak. They are dependent, but not too much. But not too much. And this is a hand waving here. Not too much is hand waving here. Later in the course, हमें वो पता चलेगा कि dependency की जो है वो आप उसको extent भी मालूम कर सकते हैं by using what we call correlations. Correlations के साथ मालूम भी कर सकते हैं वो. But we will need to wait for that. So although कि ये dependent है, but they are not too much dependent. They are not too much dependent. Okay. Now, couple of more examples which are given in the notes about the independence and dependence and how to calculate that. One thing I want to mention is that if A is independent of B, then B will also be independent of A. B will also be, if A does not impact B, then B does not impact A either. Okay. दूसरी एक और चीज कि if an event is independent of A and that event is also independent of B, then that event may not be independent of A and B together. May not be independent of A and B together. Yeah. We will pick up from here in the next lecture. If there are any questions, I can answer those questions right now. Otherwise, we will close the session. कोई question है तो पूछ लें. No questions. All right, so I'm going to stop the share and close the session, and I'll see you on Friday. We have a homework pending. Please don't forget that. Okay. All right, the office.